Hello guys. Today I'm gonna teach a topic called differentiation. It's really an important topic, an interesting topic in mathematics, and today I'm gonna explain it. A term differentiation means we can use it to find the slope of a function, like any function f of x. But here comes the challenging part. For a line, we can easily find the slope using this formula. And the formula is m equals y2 minus y1 divided by x2 minus x1. This is a formula for a line, but what if instead of a line we get a curve like this? Alright, now let me take another curve. This is a curve, so I'm selecting 2 points like here and here and drawing a line through it. And if I take 2 points and find the slope, I'm gonna get the slope for this line and not for this curve. So how do I find it? So let me bring this point closer to this point. Let's say this point is A and this is B. So if I bring this B close to A, let me just zoom this part. It's an arc, and here's A, here's B, and I get a straight line like this, right? So here it's, let me take A as x2 comma y2, B equals to x1 comma y1. So this must be x1 and this equals x2. Similarly, right here it's y2, y2, and it's y1, right? Now what is the slope we get right here? y2 minus y1 divided by x2 minus x1. Now this is an equation to find, this is a formula to find the slope which I wrote here, but it's still not intersecting at the exact curve. Like let's say x2 minus x1 equals to h, and the h approaches to 0. But what happens? It is equal to 0. We get no problem? No, we get a problem. That is y2 minus, it's the same exact point, so y2 divided by x2 minus x2. So we get 0 by 0. We can't define this form. So that the thing which we have to do is, we gotta take h is approaching to 0. If h is a big value like 1, we don't get the perfect line, a tangent for that curve. Let's say a tangent, let's say this is a curve and this is a line. It only intersects on one point on this curve. Alright, so h must approaches to 0. Let me say what is approach. Approach means, let's say it's approaching to 0, it's 10 power minus 50 trillion or something. So it's very close to 0, either on negative or positive, like minus 10 power minus 5 trillion something. Both are like approaching to 0, but different side. This is a number line, one from this side and one from this side, but both are approaching the zeros. Now you can write limit h approaches 0, and you can just write this equation: y2 minus y1 divided by x2 minus x1. And we just took x2 minus x1 equals to h, right? Then what is x1 right here? It's x2 minus h. And what is x2? And that is equals to x1 plus h, right? So now what we are gonna do is we gotta simplify this. Now we can just write y2 is equals to f of x2 and y1 equals f of x1. So both are same really. So we can just write limit h is approaching to 0, f of x2 minus f of x1 divided by what is x2 right here? X1 plus h. So we can write x1 plus h minus the same x1, right? So they get cancelled. Now limit h approaches to 0 and f of x2 is f of x1 plus h minus f of x1 divided by, we just got the denominator as h, and this is nothing but f dash of x1. If you change x1 equals x, we get f dash of x, or dy by dx simply equals lt h approaches to 0 f of x, it's minus f of x divided by h. And this is how differentiation, like what to say, now we can take any function. Example, I'm taking sine of x, and what's the differentiation of sine of x? I'm doing something. We should just put sine of x in this value, so we get something. Now limit h approaches to 0, sine of x plus h, and sine of x plus h is, sine of a plus b, which is a sine a cos b plus cos a sine b, and we just apply that rule right here. Sine of x cos h plus cos x sine h minus sine of x divided by h, and we can simply say cos h, which is h approaches to 0, so cos 0 is generally 1, so we take limit h approaches to 0 sine of x plus cos of x, and for small angles here h is very small, so for small angle we can take sine of h is equal to h, so h cos x minus sine of x divided by h. Now we can cancel these both out. Now limit h approaches to 0, h cos x by h, and we can cancel this both h, it's nothing but cos x. And here's the thing, everyone just like remembering this rule and don't know how to do it, and this is the proof for differentiation of cos x equals to, differentiation of sin x equals to cos x, and you can just do it for any function. It doesn't matter, it must be differentiable at some value, and just not like step function or greatest integer function, which is graph look like this, something like this. So it's not continuous or differentiable, so we can't differentiate this function, and this is what differentiation is generally about. Now I hope you like this video, so subscribe. Bye.